Have you ever wondered if a machine could continuously operate without an energy source? Well, this idea isn't new. It's as old as human curiosity itself, and it's known as a perpetual motion machine. A perpetual motion machine, in theory, is a device that once set in motion would continue to operate indefinitely without any external energy input. It's a concept that has captivated the minds of many, from humble inventors in their backyards to prodigious scientists in their high-tech labs. The allure of such a machine is undeniable. It promises unlimited and free energy. No more power outages, no more fuel shortages, and no more worries about depleting resources. Imagine a world where your car never needs refueling, where factories run round the clock without a break, and where power plants are relics of the past. It's a utopia that has bewitched the human imagination for centuries. However, it's important to remember that this is a theoretical concept. The term perpetual motion itself is a bit of a misnomer. It gives the impression that it's about motion that never ends. But it's not just about endless motion. It's about motion without energy. The true enigma of a perpetual motion machine lies in its proposition of continuous operation without any energy input. The concept has been around since the Middle Ages, and it has spurred countless attempts to create such a machine. From Leonardo da Vinci's designs in the 16th century to modern-day inventors filing patents for their designs, the quest for a perpetual motion machine has spanned centuries and continents. This enduring fascination reflects our innate desire to transcend limitations, to push boundaries, and to solve the unsolvable. Despite this, the perpetual motion machine remains just that, a concept, a theoretical idea, a fantasy. But why? Why, despite the allure and the centuries of attempts, does the perpetual motion machine remain in the realm of fantasy? Now let's delve into why such a machine remains a fantasy despite the allure. To comprehend why perpetual motion machines are an impossibility, we need to understand a fundamental principle of physics, the law of conservation of energy. At its core, this law posits a simple, yet profound truth. Energy cannot be created or destroyed. It can only be transformed from one form to another. Picture a pendulum swinging back and forth. The kinetic energy of the moving pendulum is converted into potential energy at the peaks of its swing, and then back into kinetic energy as it descends. This ongoing transformation of energy is a dance that plays out across the universe, from the spin of electrons around an atomic nucleus to the colossal fusion reactions powering our sun. Yet in each of these instances, the total amount of energy remains constant. Let's delve further. Imagine a skier at the top of a mountain. She possesses potential energy due to her height. As she descends, this potential energy is converted into kinetic energy, the energy of motion. If we were to somehow tally up the total energy at the top and at the bottom of the mountain, we would find it to be the same. Of course, in the real world, things are a bit more complex. As the skier descends, some of her kinetic energy is lost, as heat due to friction with the snow, air resistance, and even the sound of her skis gliding across the surface. This energy hasn't vanished, though. It's simply transformed into another form, maintaining the total energy balance. This is the crux of the law of conservation of energy. All energy in a closed system must remain constant. It can change forms, yes, but the total amount of energy cannot increase or decrease. So where does this leave our elusive perpetual motion machine? Well, such a machine would require a continuous loop of energy transformation without any loss, an impossible feat according to our understanding of physics. In essence, a perpetual motion machine would violate this law, as it would create energy from nothing. A second principle that renders perpetual motion machines impossible is the second law of thermodynamics. This law, as fundamental to our understanding of the universe as gravity or the speed of light, establishes a cardinal rule of energy behavior. To put it in layman's terms, the second law of thermodynamics states that the total entropy or disorder of an isolated system can never decrease over time. It can only remain the same or increase. This is because energy, when it is transformed or transferred, tends to move towards a state of greater disorder. Imagine a hot cup of coffee sitting in a cold room. Over time, the heat from the coffee disperses into the room until the temperature between the coffee and the room equalizes. This is an example of energy moving from a state of order or low entropy to a state of disorder or high entropy. The energy becomes more spread out, more disorganized. Now, let's relate this to the concept of a perpetual motion machine. Such a machine would require a system to maintain the same energy level indefinitely, without any loss or gain. But this contradicts the second law of thermodynamics. Energy naturally tends to spread out and become disorganized. It wants to move to a state of higher entropy, not stay in a state of perfect order. A perpetual motion machine would therefore require a perfect transfer or transformation of energy, with absolutely no entropy increase. However, in the real world, this is not possible. Every process, every energy transfer or transformation leads to some increase in entropy, no matter how small. So the second law of thermodynamics, this intrinsic rule of the universe, stands as a firm barrier to the existence of perpetual motion machines. It's a law that governs not just our understanding of energy, but the very nature of the universe itself. Thus, a perpetual motion machine, by its very definition, would defy this law, as it would require a system to maintain the same energy level indefinitely. Now that we understand the theoretical impossibility of perpetual motion machines, let us consider their practical implications. If a perpetual motion machine were feasible, it would revolutionize our world. The concept of unlimited, self-sustaining energy would dismantle our current understanding of energy production and consumption. Present energy systems rely on fuel sources that are finite and often environmentally damaging. A perpetual motion machine would eliminate the need for such resources, offering a clean, limitless power source. In an energy-hungry world, such a machine would be a panacea. It would solve the energy crisis, provide a solution to climate change, and even enable space exploration to distances currently unimaginable due to fuel constraints. We're talking about a world with no power outages, no utility bills, and no concerns about energy depletion. It's a tantalizing prospect, isn't it? However, it's important to bear in mind the potential consequences. In a world powered by perpetual motion machines, energy would essentially be free, upsetting economic systems based on energy scarcity. Industries reliant on traditional energy sources would collapse, leading to a massive shift in global economies. This could result in significant job losses and economic instability. Moreover, the availability of limitless energy could lead to excessive consumption and waste, as there would be no incentive to conserve energy. We might find ourselves living in an energy-gluttonous society with unforeseen environmental impacts. And let's not forget, the advent of such a machine could also give rise to new forms of weaponization. An energy source that never depletes could be exploited for destructive purposes, posing a significant threat to global security. But we're getting ahead of ourselves. These are all hypothetical scenarios, entertaining as they may be. In reality, the laws of physics ensure that we cannot get something for nothing, not even with a supposed perpetual motion machine. In conclusion, the laws of physics make perpetual motion machines an impossibility. This idea, as alluring as it may sound, is an elusive dream that has captivated countless inventors and thinkers throughout history, yet remains unattainable due to the very rules that govern our universe. Let's revisit the key points we've covered. Firstly, we discussed the concept of perpetual motion and its tantalizing promise of limitless, self-sustaining energy. We then delved into the principle of energy conservation, a fundamental law of physics that mandates energy cannot be created or destroyed, only transformed. This law underscores the fact that a machine cannot generate more energy than it consumes. Next, we explored the second law of thermodynamics, a pillar of physics that deals with the concept of entropy and the natural progression towards disorder in the universe. This law states that energy transfer or transformation is never 100% efficient. Some energy is always lost as waste heat. Thus, no machine can operate indefinitely without an external energy source to compensate for this inevitable energy loss. These principles of physics are not mere academic curiosities. They have practical implications that shape our world. From the cars we drive to the electricity that powers our homes, these laws dictate the functionality of every machine and system we interact with. They provide us with a framework for understanding and navigating the world around us. In essence, the quest for perpetual motion is a journey against the tide of physics. It's a testament to human curiosity and the relentless pursuit of knowledge. Yet, it's also a reminder of the boundaries set by the universe itself. The allure of perpetual motion machines remains, but the reality of physics brings us back to Earth. The laws that govern our universe, while they may limit our dreams of endless energy, also provide a blueprint for the incredible technological advancements we've achieved and the ones yet to come. In the grand scheme of things, these laws aren't constraints, but rather they are the very guidelines that facilitate our progress.